Hi everyone. In this video I'll be showing you how you can write Verilog code in ModelSim, how you can compile that code into a model that you can simulate, and how you can actually simulate that model all inside of ModelSim. And for this demonstration I'll be using ModelSim Altera, which is a special version of ModelSim that you can download for free from the Altera website, www.altera.com. I'm starting with a brand new install of ModelSim here. I just launched the program and I'm presented with this welcome window, which I'll close. The first thing I want to do is create a new project, and a project is a collection of resources that ModelSim will consider to be related to one another in some way. So to create a new project, I click File, New, Project. Here I'll give the project a name. I'll name it My New Project and click OK. So now I have a new project, but there are no items inside the project. And I can tell that here because I'm viewing the project panel. And by the way, if you don't see the project panel on your screen, you can enable it by clicking View up here in the toolbar, finding Project in the list of panels that appears, and clicking it so that it has a check mark next to it. And that will make the project panel visible. On my screen it's already visible, so I don't have to do that. I'm going to take advantage of this little wizard that popped up asking me if I want to add an item to the project. And yes, I do. I don't have any items in this project, and I want to add one Verilog source code file. So I'll click Create New File, and I'll select the type of file to be Verilog instead of VHDL, which was the default. So I'll choose Verilog here, and I'll create a file name. I'll specify a file name. And I'm going to make a Verilog file that models an inverter logic gate. So I'm going to name my file My Inverter. And I'll click OK, and I want you to watch what happens in this project panel here when I click OK. Okay, and I'm going to close this wizard because I only needed to create one file. I don't need to create any of these other things. And I think you'll have noticed that as soon as I added that item to this project, a new entry appeared here in my project panel. This is a file that ModelSim has created for me based on what I input into that window. It's using the item name, and it has added a .v suffix because the file type that I chose was Verilog, and .v corresponds to a Verilog source code file. So now that I have a file, I want to actually add Verilog code to that file. So how do I do that? I right click on the item and select Edit. And I think you'll have noticed here on the right side of my screen a text editor became visible. And this is a text editor that's built into ModelSim, and it offers some syntax highlighting. In other words, if I use some Verilog keywords, ModelSim will show them in a different color than the default black text. So here I'm going to write my Verilog code. I'll start off with a comment to remind me what I'm doing in this file. I'm going to model an inverter logic gate. Okay, so I need to create a Verilog module. I'll use the keyword module, and I need to give the module a name, My Inverter, and that name does not have to match the file name, but in this case I'm making them match. And now I need to include a port list, the inputs and outputs to this module. Now I'm making a one input, one output inverter. So I'm going to specify one input, and I'll call that My Input. And I'll specify one output, and I'll call that My Output. And I'll close the port list there. Next, I want to specify what direction each of those ports is in. So I want my input to be in the input direction, an input to my module. So I'll use the Verilog keyword input and type the port name input, my input. And similarly, I want my output to be an output from my module. So I'll use the keyword, the Verilog keyword output, my output. So this code right here is going to tell the compiler that I want my input, the my input net or wire, to act as an input to my inverter module, and the opposite for my output. That will be an output. And the last thing I need to do is specify how I want the output of this module to be generated. And I want the output to take on the value of the inverse, and I'm using that tilde symbol to indicate inverse, the inverse of the input. In other words, if the input is a 1, output is a 0, or output will be generated as 0. If the input is a 0, I want the output to be generated as a 1, so it's the opposite, and that's what this tilde symbol will do. And to end my module, I use the keyword end module. Oop. End module, there we go. So now I'll save this, click the save icon here, and compile it. How do I compile? I right click the item inside my project, hover over compile, and click compile selected. And I want you to watch that question mark icon here. I think you'll have noticed it turned from a blue question mark into a green check mark, and that means the compilation was successful. And I can also see that here in the transcript panel, that compile of myinverter.v, my text file, my Verilog file right here, was successful. So now I've compiled what used to be just text or source code into a model that I can then simulate. So now I want to simulate it. How do I do that? Well, I go to the library panel here, select that, and find the work library. Now work is the name of the library that I had indicated earlier in this process. At the time when I created the project, I specified that I wanted the default library name to be work, and I didn't actually specify that. That's the default name that ModelSim uses. I just didn't change it. So I know that my library, which is going to hold the models that I can simulate, is named work. So I'll expand the library and find the model that I want to simulate inside there. And I want to simulate the myInverter module. So to do that, I'll right click on the module and click simulate. And I want you to watch the layout window up here. It changed from no design to simulate, and you might have noticed the layout of the screen here changed a little bit. Instead of viewing the library panel here, it automatically is showing me the sim panel. So now I want to see how the output of the myInverter module behaves relative to the input. So when I make some change on the input, how does the output respond? So I want to view the waveform viewer here so that I can see what my input wave looks like and what my output wave looks like at a given time. And right now I'm not viewing any inputs or outputs, so I'll need to add those to the waveform viewer. And how do I do that? Well, I'll find the I'll make sure that my module is selected here in the sim panel, and then in the objects panel I'll see all of the viewable signals that I could possibly add to the wave viewer. And I want to view the my input signal, which is the input to my module, and I want to view the my output signal, which is the output from my module. So those are the two signals I want to view. But I haven't specified any values for the input yet, and I want to do that before I simulate this module, simulate its behavior. So I'm going to force the input to be a 1, and I want my module, I expect my module to produce the opposite value on its output, because I wrote code that model's an inverter. So when I set the input to 1, I expect the output to be 0. So I'm going to force my input to be 1. How do I force my input to be a certain value? I right-click on the input and select Force from the menu. And under Value, I type the value I want to force it to, which in this case is 1. So I enter 1, push OK. And then I want to run the simulation. And I expect my output to be 0 because the input is 1. So how do I run the simulation? Well, there's a button up here called Run, or you can press the shortcut key F9. I'm going to click this button, and it's going to run the simulation. And how long is it going to run it for? It's going to run it for whatever time is written in this box. And this is currently set to 100 picoseconds. And so when I run this, you'll see 100 picoseconds worth of simulation show up here. So when I run that, now you can see that little 100 picoseconds as opposed to 1 nanosecond, 2 nanoseconds, 3 nanoseconds. So just because this window is set to show 3 or more nanoseconds worth of system time, I only simulated what's shown in this box, which is 100 picoseconds. So in order to see what's going on there, I'm going to zoom in with this zoom in button. I'm going to keep clicking that. And actually I want to fit it automatically to the size of this waveform viewer here, so I'll click this zoom full button, and you might have noticed it expanded to fit this panel almost fully. And you can measure how much time was simulated. I can see here on the bottom there's a time meter, and the waveform ends at 0.1 nanoseconds, which is equal to 100 picoseconds. It's the same amount of time. Okay, so I can see that when my input is 1, my output is 0, and that is what I expect for an inverter. Now I want to simulate what happens to my output when my input is 0, and I know I expect the output to be 1. So again, I'm going to, it doesn't matter where my cursor is, because the next simulation will start at the end of the previous one. So even if my cursor's over here, the next simulation will start right here, because that's where these waveforms ended. So I'm going to right click my input, select Force, and under Value I'm going to set that to the value I want to force this input to be, which in this case will be 0. So I'll type 0, push enter, and I'll run the simulation again. And now I'm a little disoriented, so I'm going to zoom out a little bit, click zoom full so I can see all the simulation I've done so far. So remember, this was the first simulation I did, which had the input set to 1 and showed that the output would be 0. And this second simulation is the one I most recently did, which has the input set to 0 and the output being generated as 1. So this model is behaving exactly like I want. In this video I've shown you how I can write Verilog code in ModelSim, how I can compile that Verilog code using ModelSim, which was by right-clicking on the item in my project panel, hovering over compile and clicking compile selected, or clicking this shortcut icon up here. I forgot to show you that earlier, but there's a compile button that does the same thing as right-clicking compile, compile selected. So I've shown you can write the code, compile the code, and simulate the code. And remember, to simulate it, I want you to find it in the library panel in your work library, right-click the module you want to simulate, and click Simulate. Thanks for watching.